Hello and welcome to another instance of our workshops for the finite method analysis class. For this workshop, we're going to use the frame surface created in the previous workshop, workshop number 5, and we're going to analyze it with our method and induce a few stresses and pressures on it to see how it responds and to further better our pattern abilities. Now, what we're going to do is we're going to create a group. Since our file is already imported, we're going to create a group and we're going to call it new group. We're going to call it FEM, finite element method surfaces, and we're going to make it the current one. And now we're going to apply. Now we're going to create a mesh. So we're going to go right into meshing, and we're going to create a mesh on the surface. It's going to be a quad. The mesher, we're going to use a paper mesh and a quad 4. And under the surface list, we're going to select all surfaces. So I'm just going to drag all over this. And it's 1 through 182. The global length, I'm not going to do an automatic calculation. We're just going to set it at 1. And we're going to click apply. So as you can see, the mesh is being created and it is almost done. And that's our mesh. Our next step is creating the equivalence, or more of extracting the equivalence nodes for our benefit. So what we're going to do is we're going to go to equivalence, all in tolerance cube, and the equivalence tolerance, we're going to set it at 5 thousandths, and we're just going to hit apply. Due to our sales agreement with the MSC company, we had to edit our meshing. So instead of meshing at 1 pattern unit, we used 2. So it's not going to give us an answer as precise, but it will allow us to extract the equivalence nodes, which are shown in the bright purple. And through this, it's going to be a lot easier to work with. Our next step after the equivalence nodes is we're going to show the element free edges, and we're going to go to verify, element boundaries, and the display type, we're going to go free edges, and we're going to click apply. So that's the free edges of our workshop. With our free edges now, we're going to verify the elements. So we're going to stay in verify, but we're going to go to quad, and we're going to do the aspect. So it tells us to do it at a 1. The aspect ratio, we're going to set it at 5, which is a preset, and we're just going to go ahead and click apply. And that is our test, as you can see from the results. Once this is done, our next step is going to be posting the all surfaces group. So we're going to click post. I'm just going to select all surfaces and apply. And we're going to hit cancel right away. This gives way to our next element. So we're just going to show you how our model's looking till now. So this is it, and we're gonna show you that this area right here, which is where most of the nodes are, and you can see the differences in shape. Now what we want is we're going to create a dead load from an engine for this model. So what we're going to do is we're going to go to load and boundary conditions. We're going to create a force nodal, and in the new set name we're just going to call it a dead underscore load. The input data, it must not appear on the screen, but I will dictate for you. It's going to be 0, -150, and 0 for surf load, F1 and F2 and F3. So we're just going to go 0, -150, and 0. I'm going to go ahead and click OK. And now our application region. And make sure to hit, for the geometry filter, we're just going to select geometric entity. And under select geometry entities, we're going to select the points that are mandated. It's going to be point 360. Go ahead and click add, and then we're going to hit OK. And apply. A minor correction we made was selecting point 360. That is not an actual point, it's point 3 and 60. I missed a spacebar hit. And we're going to click apply the dead load, and now we can see both loads being applied on the negative y axis. Now we're going to create another dead load. So we're going to call it dead underscore load underscore 2. And the input data is going to change a bit. We're going to have a negative force on y of 960 units. And again, we're just going to click OK on that. Select our application region. And now it's going to be point 37 and 50, which is the same points on an opposite end. So now that we have our working load, we're going to create an operating engine, just our static load for the engine. So we're going to create another load like we had before, and it's going to be a force, and we're going to call it just OP for operating underscore static underscore load. And the input data, we're just going to create the force of 0 on X, -100 on Y, and -100 on Z. We're going to click OK and select our application region. The application region is going to consist of our geometry, and we're going to add points 37 and 80 as well. We're going to click OK and just apply our force. As you can see, the resultant force on those points has changed, and now we can see a light inclination and a change on the value of the resultant. Now we're going to create the gravitational force applied on the frame. So we're just gonna create, instead of a force, we're gonna call it an inertial load, and we're gonna set the name to gravity. We call it an inertial load because it has an acceleration. So our acceleration is gonna be 0, negative 386.4, and 0. I'm gonna hit OK and apply. Actually, yeah. Our next step is to create constraints for the movement or displacement, and what we're gonna do is we're gonna call it a fixed base, and for our input data we're gonna give the translations values of 0. OK, and we're going to select the application region, and we're going to select geometry, and under geometry entities we're going to pick the points 52, 1, 90, and 98. I'm going to type points right ahead, and I'm going to change it to, well, we have it on wireframe already, so we don't have to change it. And the points are shown. We're going to click add, now that our constraints have been created, we're going to select a different view just to show what we've done. So that's the ISO view. As you can see on the edges, the 1, 2, 3s in the light blue are the constraints for the translation. Now we're going to go into display, and we're going to select the load element properties. And what we're going to do is we're going to unselect the show LBCE element properties values. After this, we're going to hit apply, cancel, and this is what we need right now. We just didn't want to show the values at this point. Now we're going to select our material. So it's going to be an isotropic material, and we're going to call it aluminum, and our properties for aluminum are 10 times e to the 6th for the elastic modulus, and the Poisson ratio is going to be 0.3, and our density is going to be 2.61 e times the 10 to the negative 4th. We'll hit OK in the properties, and then we'll hit apply. Now we're going to select the properties for the frame structure, and under properties it's going to be 2D properties. We're going to select a shell, and we're going to name it aluminum frame, and we're going to abbreviate that al frame flange. And then under input properties we're going to select the material we created, and we're going to call the thickness 3/4 of a unit. Hit OK. And we're going to apply it. After selecting the material for the flanges, now we have selected the material for the webs between them, and we selected a thickness of uh, half a unit. Now what we're gonna do, as you can see, we already selected the surfaces. We're gonna hit OK, and we're gonna apply. It already exists. That's what it says here. You may not be able to see it, but we're gonna click yes just to make sure. And now the properties have been set, and we're gonna go right into our load cases in load PCS just to check that everything's in order. And to make sure the cases are right. We're now here in the load case window, and we're going to click modify. And we're going to hit the default, and a window pops up, and we're just going to check that all the loads and the boundary constraints are set. And as we can see, we do have all our loads applied to the same scale factor. With that, we hit OK, and now we hit cancel. And now we're going to post a group. We're going to post the FEM surfaces. We're going to hit apply and cancel. I'm going to go ahead and just go back to our regular view, our ISO 1 view. And now we're going to do the analysis. We go into the analysis section, and we're going to do an entire model full run. Our solution type is going to be a linear static, and output format we also want to see the fringe results, so we're going to go to create fringe, and we're going to select the stress tensor. It's very important to make sure we have it in von Mises. In the position, we're going to select ATZ1, close, just to make sure it's in von Mises, and we're going to apply it. And these are the stresses it's been applied. It's been under. And this is the results we obtained from our analysis. In conclusion, these are the results we obtained from our workshop number 6. I'm sorry. in which we use the results from workshop number 4 to create an analysis of subsequent loads applied on the frame of an engine. Thank you very much, and until the next edition.